बिल्कुल दोस्त, अभी बीएमएस फंडामेंटल्स को एक प्रॉपर मास्टर टॉपिक मॉड्यूल बनाते हैं, ऐसा कि तुम इसे कोर्स, नोटबुक और फ्यूचर एमबीओज रिसर्च में रेफरेंस के लिए यूज कर सको। वेलकम बैक एवरीवन। आई एम incredibly excited to guide you through this explainer today. We're going to take a really deep, structured dive into the foundational bedrock of modern infrastructure, the Building Management System, or BMS. By the time we wrap up, you'll have a complete top-to-bottom understanding of how smart buildings actually work in the real world.
To really get this, I want you to totally flip how you look at a massive modern building. Don't just see it as this static, dead pile of concrete, glass, and steel. Instead, I want you to imagine it as a living, breathing organism. Literally, just like your own body, a building has to regulate its internal temperature. It needs to inhale fresh air, exhale stale air, circulate fluids all over the place, and smartly manage its energy. And exactly like a complex living thing, to coordinate all those massive internal organs, it desperately needs a highly intelligent centralized brain. And well, that central brain, that's our BMS. So here's our structured game plan for today. 1. What exactly is a BMS? 2. Objectives and core concepts. 3. The 4-level architecture. 4. Field devices and actuators. 5. BMS inputs and outputs. And finally, 6. DDC and HVAC integration. Let's jump right in.
All right, Section 1. What is a BMS? The brain of the building.
Just think for a second about the sheer scale of the facilities we built today. We're talking sprawling commercial office blocks, 24/7 healthcare campuses, massive luxury hotels, giant transport hubs like airports, hypercritical data centers, and heavy industrial plants. You can't just have a massive team of humans literally running around flipping switches, reading physical thermometers, and twisting valves by hand to keep the environment perfect. I mean, no way. It's totally impossible. These huge, complex beasts absolutely rely on centralized, automated operation just to function safely, let alone efficiently. Moving on to Section 2, Objectives and Core Concepts, the Reflex Loop. Okay, so the most crucial thing to understand here is this fundamental 3-step loop. Sense, process, actuate. It's literally just like your own human reflexes. Imagine accidentally touching a hot stove. The nerve endings in your finger, those are your sensors, detect that extreme heat. That data flashes up to your brain, which processes the info and instantly decides, uh-oh, danger, move. Then your brain shoots a command to your muscles, your actuators, to yank your hand away. Well, a BMS does the exact same thing. A sensor notices, say, the carbon dioxide levels in a packed conference room are getting way too high. The local controller processes that, sees it's over the limit, and fires an electrical command to actuate or open up a fresh air damper to let the building breathe. Sense, process, actuate. Beautiful, right? And here's the kicker. All of those millions of tiny micro-reflex decisions happening every single minute, they all funnel into one unified thing: centralized operation. The BMS allows us to hit top-tier energy optimization, dial in precise comfort, and manage critical alarms without ever leaving our desk. It's the whole shebang on a single screen. Let's look at how it's built. Section 3, the 4-level architecture, the spine of the system. Let's walk right up the spine of the building. Down at the very bottom, we have the field level. This is the physical world, right? Sensors measuring actual air temperature, actuators turning real physical valves. That raw data travels up to the control level. This is where programmable DDC controllers process the inputs and make fast, local decisions. From there, the data flows up into the supervisory level, your main BMS server. This is where a human operator is actually looking at graphics, checking alarms, and tweaking schedules. And finally, at the very top, is the management or integration level, where we pull all that data into advanced analytics, generate energy reports, and tie it into enterprise cloud platforms. Now, to make sure all these levels can actually talk to each other, we use specific networking protocols. You'll hear names like BACnet and Modbus. Think of these as a specialized language that connects all the heavy-duty chillers, the air handlers, and the energy meters back to the central brain. Something like BACnet over IP is amazing because it ensures that devices from totally different manufacturers can plug in and seamlessly chat on the exact same network. Okay, Section 4, Field Devices and Actuators, the senses and the muscles. So let's talk about the senses first, the eyes and the skin of our building. These field sensors are relentlessly, constantly gathering data on the indoor environment. We've got sensors feeling the temperature and humidity in the offices. Others are sniffing out CO2 and measuring airflow in the ducts. You've got pressure sensors checking if filters are clogged, occupancy sensors to see if someone's actually in a room, and flow meters tracking water and energy. They're constantly generating the raw data the building needs to essentially feel its own state. And then, once the system feels an issue and makes a decision to act, these guys take over, the actuators and devices. These are the muscles doing the heavy lifting. We have damper actuators, physically twisting heavy metal blades to change the airflow. We've got motorized control valves sliding open or closed to push chilled or hot water into coils. Then there are VFDs, variable frequency drives, that dynamically ramp up or dial down the speed of giant electric motors. And of course, relays and contactors, snapping shut with a loud clack to fire up huge pumps and exhaust fans. Which brings us to Section 5, BMS inputs and outputs, decoding the data. All right, if you take nothing else away, memorize this 2x2 matrix. It's absolutely crucial. Every single data point in a BMS is either an input coming from a sensor or an output going to an actuator. Simple enough, but electrically, those signals are split into two types, digital or analog. A digital signal is binary, simple, on or off, yes or no, 1 or 0. So a digital input would be a switch saying, yes, the fan is running, or hey, there's a pump fault. A digital output is a command, start the pump or stop the fan. An analog signal, on the other hand, is a continuous sliding scale. So an analog input is a variable measurement, like the temperature is exactly 22.5 degrees or CO2 is at 800 parts per million. And an analog output, that's a variable command, like telling a valve to open to exactly 45% or telling a VFD to run a motor at 60 hertz. So just remember, digital is for specific states and analog is for variable ranges. Moving on to our final section, number 6. DDC and HVAC integration, the localized brains.
DDC stands for Direct Digital Control, and honestly, these little guys deserve their own spotlight. A DDC is essentially a small, rugged computer sitting inside a metal control panel right next to the equipment on the floor. It reads those field inputs, runs its programmed logic, and commands the outputs. And here is why DDCs are total lifesavers. They operate completely independently. Seriously, if a main network cable gets sliced by a contractor or the central server crashes, these local brain cells just keep chugging along. They make sure the HVAC keeps running safely so the building doesn't literally suffocate just because a computer went offline. When you zoom out and look at a complete picture of a facility's MEP services, mechanical, electrical, and plumbing, the true scale of what a DDC does is just mind-blowing. The DDC network is managing massive HVAC organs, the air handling units, the chiller plant in the basement, the massive cooling towers on the roof. But wait, it doesn't stop there. With modern integration, the BMS also hooks into the fire alarm systems, the security and access controls, the lighting grids, and the main electrical supply. All of these separate, massive subsystems get woven together into one unified, highly intelligent organism.
And finally, all of this underlying complexity, all those sensors, the muscles, the BACnet protocols, the DDCs we just talked about, it all culminates right here, the BMS dashboard. This is the visual interface, the steering wheel for the facility manager. From this one single screen, they can instantly read chilled water temperatures, monitor the exact load of those cooling towers, verify the domestic water tanks are full, and make sure the electrical transformers aren't overheating. It takes millions of invisible data points and distills them into crystal clear, actionable intelligence. So, we've seen exactly how a BMS acts as the vital brain and nervous system of a modern facility. But I want to leave you with a thought to chew on as we wrap up. As the number of IoT devices absolutely explodes, and we start baking deep AI and machine learning into these systems, we are crossing a totally new threshold. What happens to our jobs and our buildings when the system stops just reacting to our set points and starts actually predicting our needs? When it optimizes its own code and starts thinking entirely for itself? It's a wildly fascinating future, and mastering these fundamentals right now is your ticket to being part of it. Thank you so much for joining me on this explainer today, and I'll catch you next time.